Okay. Now you do have access to these solutions, but I think it's better if you actually see someone working out. I'm not going to have time to do it during class, so here we go. This is a practical application of a polynomial. It is one of the success criteria. Which one I don't remember, and it's one of the questions I asked you to do. So we've got this thing. So Amy is on a roller coaster ride. Lucky Amy. First part of the roller coaster ride can be modeled by this function, where h is the height above the ground and x is the horizontal distance from the starting point. What is the height of the stairs Amy has to climb to get onto the ride? Whereabouts? Where will the stairs meet the ride? At the starting point, and x is the distance from the starting point. So what do we have to do? What do we have to let x equal? Well, we've got to let it equal 0. So let's define this thing. I don't know how much I recorded, but let's just go through that again. So it says 48 seconds. Anyhow, we're modeling the height, x meters away from the starting point. We want to find out the height of the stairs Amy has to climb to get onto the ride. Well, the ride starts at the starting point, so that'll be where x equals 0. So let's open up CAS, and I'm going to define h of x equals this thing here, which is negative 1 over 5, open the set of brackets, and I'm going to say x cubed minus 15x squared plus 40x minus 32. Alright, that's what we've got there. So I think it's a good idea if you graph it. So let's go to this. Let's graph this thing, h of x. And here we have the roller coaster being modeled, and it's massive, but that's okay. Just check to make sure I've entered it incorrectly. Yep, okay, that's fine. Okay, so we want to find out what it's going to be at the start. So we'll say h of 0. Whoops. H of 0, and then h of x, h of 0. 32 over 5. So she's got to climb 32 over 5 meters. So did they tell us what? So that's what we have there. So 32 over 5 meters is that answer. Let's scroll down to B. Too far. Got the wrong question. So hang on. So Amy's on the roller coaster ride. What does she have to do to climb on the ride? Alright, okay. So now it's asking us to sketch the graph over these, over that domain. So sometimes they try to pull a Swifty on you. 0 to 15, you're not going to be using any of this here. So let's restrict the domain. So to restrict the domain, we'll say, I'm going to go back up here, and I'm going to say where 0 is less than or equal to x, and x is less than or equal to 15. And then I can go back to my graph, and I can see that's where it's gone to. Whoops. So I will zoom out a little bit. Window zoom out. And that's ridiculous. That doesn't seem right. Let's go back to the previous page. And I am saying go between 0 and 15. Well, let's go back to the other page, and well, there's 15. It must drop a fair way down. Who knows? Maybe it's a scary ride. I don't know. That just seems a little bit weird, so I'll be checking that to make sure I've entered it in correctly. Negative 1 over 5. Negative 1 over 5, yep. X cubed, 15x squared, 40x, minus 32. Oh, it's a ride that goes 100 meters underground. I don't know, but then you'd be graphing that. It tells you now label any axis intercepts, turning points, and endpoints. So we've already got one endpoint. We've got this endpoint here. So we've got one endpoint, and we know this endpoint happens at 15. So what we'll do is we'll go back to this. So for the endpoint at 15, so we got h of 15. We have negative 5 and then negative about 100, or that's what we'd say. So we'd say this. So we'd say this endpoint is at 15 and what does it tell us? Negative 568 over 5. Then we know to label some turning points as well. So whoops, wrong way. So we are moving the graph. So we'll go menu, analyze graph, minimum between here and here, and there's one of our turning points. Analyze graph, maximum between here and here, and then we've been putting that down as well. At this point, I think that's about as accurate as you can get with a cubic. We haven't done calculus, which will cover that and give us an exact values. But we've got our leftmost point. Our two turning points are our intercepts. Menu, analyze graph, 0, going from here and here. Times that happens at 11.9. To be more accurate, you need an exact answer. You'll say solve. This is why we define functions. H of x for 0 for x happens at that. That's about as good as we can get. So we do that. If it gives you you should get an exact answer. For some reason, I haven't. It may not be able to give me one because I specified the domain or something. I don't know, but that's what I'll be looking at. Okay, now what else do I? So over which interval of the horizontal distance is Amy more than 20 meters above the ground? Give your answer to decimal place. Okay, so we want to see where she's 20 meters above the ground. Well, for that, we can go to the graph, and if she's more than 20 meters above the ground, that means we're going to draw another graph at y equals 20. So we'll say 20, and we're going to find some intersection points. Analyze graph, intersection, here and here, and we're going to do it again. Menu, intersection, analyze graph, intersection between here and here. So that's gone from 5.52 to 10.6, and we just subtract those two values because it's asked for a distance over which interval. So that's the interval is between 5.52 and 10.60. We'd say the other option is we could say solve h of x for 20. And here it is, 5.52 and 10.64. We could do that as well. Okay, the other one I ask you to do from this exam is question 4a. All right, let's have a look at this thing. Function f of x equals square root of x undergoes the following things. So a reflection in the x-axis, a dilation factor 2 from y, translation 1, and then a translation 3 in the negative y-axis. Okay, I'll just pause that while Mrs. Marcock explains something to one of the Miss Marcocks in the house. All right, so let's see. So we've got this thing, y equals the square root of x. So I'm going to make a new graphing page. And I'm going to say we've got tab the square root of x. So that's what we have, the square root of x. Now, so a reflection in the x-axis. Now, I know that means we are reflecting that function. So I'm going to go up to here, and I'm going to say we're going to make this thing negative. So that's what it'll look like. Then we're dilating by 2 from y. Now, if I'm dilating by 2 from y, that means that I am putting a half in front of that x. So that's what we end up with there. Now it's translating 1 unit in the positive direction of the x-axis, so it's going that way. So that means that I am going to do this, and I'm going to say minus 1. Let's just see if that has moved the 1 across. Now, we can see it hasn't moved the 1, it's moved it 2. So what we're going to have to do, we're going to have to tab, I'm pressing tab, and I'm going to change this to take out a common factor of a half and turn this into 2. Whoops. Damn. 1. There we go. So now it's moved it to the right by 1. So what I've done there, I've taken out that common factor of a half. So based on that, then it translates 3 units in a negative direction of the y-axis. So that means I am subtracting 3 from the whole thing. Minus 3. And that's what we end up with there. So the new function, we've got that there. The point lies on that, so we want to find the new one. Find the new point under these transformations. So it was originally 1 and 1. It was originally, so let's go. Can we undo a whole bunch of stuff? Control Z, Control Z, Control Z, Control Z, Control Z. You can do the same. Control Z works. So the point 1 and 1 was here. Now, whoops. Control Y, redo. So that became 1 and -1. Control Y became 1 and -1/2. Control Y, not that thing. Control Y, not that. Control Y, it's there, so it's negative. So it's 2 and -1/2. Control Y, 2 and -1/2, and it's gone down to -3.5. So now this is at 2 and -3.5. Okay, and that's about it for that one. Let's see. Question 5. Question 5. Yep, got to do question 5. It tells us if x minus 1 is a factor of this, then find the value of k. Okay, so if that's a factor of that, then we know that we end up with a, then we know that this thing here will equal 0 when x equals 1. Because it's a -1. So what we can do, we can say, on CAS, go to a new calculator page. We'll say, and we type in our equation, 3 open bracket 1, it's cubed, so I'm just going to leave it, plus 1 because it's 1 squared, plus k equals 0. So then from here we can say the k equals 4 because we're going to subtract 4 from both sides, so k equals -4. So, so if x minus 1 is a factor, then k equals -4. Now we can scroll down. Is there anything else with that question? No, that's it. So that's what we'd have to do for that one. It's only worth 2 marks. But what would we be looking for? This is what we'd look for. We'd substitute 1 into the equation, and then we'd go through that. Okay, let's see what else is there. Question 7. Oops. Question 7. Let's see. The graph of the equation y equals a over x plus k passes through these 2 points. Find the value of a and k. Well, for this kind of thing, we've got a set of simultaneous equations. So we can say we're going to solve, open set of brackets. We're going to use this, and we're going to have 2, because we're going to 2 equations. And the first one is -1 equals -1 equals a over 1, a divided by 1 plus k, and this other one is -5 because that's our y value. -5 equals a over 3, I think it is, or is it -3? -3, and still plus k. And we're solving these for a and k. A's got to equal 3 and k's got to equal -4. So that's the steps you'd take. So you would set up one equation, so you would write one equation, you would write the other equation, and then you would use this to solve. Okay, what else is there? Oh, hang on. Find the value of a and k, and then sketch the graph, labeling its asymptotes. So from there, what you do is you take, so we've got a and k, so we'd write a new function, we'll call it k of x, define, it just makes it easier, k of x equals a, which is 3 over x, plus or -4, because that's our equation, so that's what we've got there. So 3 over x, and we've got -4, which is what it is there, and then we just go to a new graph, and we're going to graph k of x, and there it is there. So from there, then we look at that and say, okay, it looks like we've got an asymptote at 0, and we should know that because we don't have x being transposed anywhere, and then we've got another asymptote at x equals -4. What else do we want to do? X-intercepts, so we'd solve k of x for 0. 3 over 4, so that's, nope, wrong one.